In this video, I'm going to go through equations with fractions. The first thing to remember is that a fraction is a division, or it represents dividing. So this could be read 2x over 7 or 2x divided by 7. And I want you to think of this as a function machine that describes what's happening to x. So we always start with x. What's the first thing we read? 2x, which means that the x was multiplied by 2. So x was multiplied by 2. Keep reading, 2x divided by 7. So the next thing that happened is a division by 7. And then we get our answer, which equals to 4. And with equations with fractions, you are reversing that process. You're starting with the answer and working backwards. So instead of a divide by 7, you're going to multiply by 7. And instead of a times 2, a multiply by 2, you're going to divide by 2. And that's going to give you the value of x. So always read the question, 2x divided by 7. The last thing you did, which is the divide by 7, is what you're going to reverse first. So if I write it, I'm going to multiply this side by 7. And I'm going to multiply this side by 7. Remember that equations are also like a balance. Whatever you do on one side, you have to do on the other to keep that balance. So the multiply by 7 here, all it does is reverse that division by 7. So it disappears. And then I've got a 4 times 7, which is 28. So I now have a 2x equals 28, which is a simple equation that I can solve by dividing by the coefficient of x, the number attached to x. So I'm dividing by 2 on both sides. 2 divided by 2 gives me 1x. It's the x that I want. And 28 divided by 2 is 14. Now, for the second example, if I read it, 3x divided by 4 add 1 equals 11. What's the last thing that I did before the equals 11? It was the add 1. And remember, with a function machine, I'm going to start from the end. I'm going to start by reversing the last thing I did to x. So if I write it out, it's an x, 3x, so it was multiplied by 3, and then divide by 4, and then we added 1, and we got the 11. So the first thing I'm going to do is I'm going to subtract 1 from both sides. Plus 1 take away 1 is 0, so that's gone. And I'm left with 3x divided by 4 equals 10 because of the 11 minus 1. So I've done the minus 1. I now have to reverse the division by 4, so I'm going to multiply both sides by 4. The times by 4 here simply cancels out the division by 4. So that's gone. And then I've got the 10 by 4, which gives me 40. So I've got 3x equals 40. And now you have a simple equation that you can solve by dividing both sides by the coefficient of x, so divided by 3, divided by 3. So 3 divided by 3 gives me 1x, which is what I want. I want to find the value of an x. And it is 40 over 3. And you don't round, and you keep your answer as a fraction. The next two examples are similar, although they might look different. This says 2 over 9x, and it could have been written as 2x over 9. It actually means exactly the same thing. 2 times x over 9 is the same as 2/9 times x. And this 1/5 x is the same as 1x over 5. And of course, 1x just means, or could mean, x over 5. So if you see something like that, don't be put off. You can rewrite it like this. So this is 2x over 9 minus 4 equals 2. And this is x divided by 5 plus 2 equals to 6. The last thing that happened here was the subtract 4. So I'm going to start by adding 4 to both sides. Minus 4 add 4 is 0. And I end up with a 2x over 9 equals 6. The last thing that has now happened is 2x divided by 9. So I'm going to multiply both sides by 9. The divide by 9 times 9 cancel each other out, leaving us with a 2x on this side. And then I've got a 6 times 9, which is 54. And then I'm going to divide both sides by 2. 2 divided by 2 is my 1x. And then the 54 divided by 2, if I do it there, you've got your 2 goes into 5 twice. And I've got the 4, I subtract. So that's a 14. So it is 27. So x is 27. For the second one, the last thing that happened was the add 2. So I'm going to take away 2 from both sides. 2 take away 2 is 0. I am left with x over 5 equals, and 6 minus 2 is 4. The last thing that happened is the divide by 5. So I'm going to multiply both sides by 5. Divide by 5 times 5 cancel, leaves me with a 1x, which is what I want, and then the 4 times 5, which is 20. So x equals 20. There's nothing more to do, no division, because I already have my 1x. And the last example combines multiplying brackets. There are actually 2 starting points to this question, so I'm going to write it out twice. 2x plus 1 over 3 equals 6. You could start by reversing the division. So divide by 3 times by 3 times by 3. The divide by 3 times 3 cancel. 6 times 3 is 18. And you now have 2 brackets x plus 1 equals 18. Or you could start by multiplying out the brackets first. 2 times x is 2x. 2 times 1 is a add 2 over 3 equals 6. And then you would multiply both sides by 3 to reverse the division. And you will have 2x plus 2 equals 18. Now, I could multiply out the bracket, or you could note that 18 is even, so it can simply divide by 2. Not subtract, not add. This is a multiplication. This is a 2 times the bracket. So to reverse the multiplication, you would divide both sides by 2. That gives us 1 times the bracket, which is x plus 1 equals 9. And then I would subtract the 1 from both sides to give me x equals 8. This might be easier. Expand the bracket, reverse the division, and then solve the equation. Take away 2 from both sides. That gives us 2x equals 16. Divide both sides by the coefficient of x, which is the number next to x, the 2. And I now have 2 divided by 2 is 1x, my x. And 16 divided by 2 is 8. So you get, of course, the same answer, whichever method you use. And these are the examples for equations with fractions.